Every single second, roughly a few thousand stars detonate violently across the observable universe, obliterating everything in their immediate vicinity. The tranquil night sky you see above is a massive, active graveyard hiding in plain sight. What you are looking at is an optical illusion, a temporary snapshot of celestial bodies waiting to be eradicated. Today, we track the brutal execution of every object in the cosmos. Our chronological journey of total destruction begins remarkably close to home. The death of a terrestrial planet is a bath of scorching plasma. In 5 billion years, our sun will exhaust its core hydrogen reserves, triggering a sudden fusion of helium. It will transform into a massive red giant, instantly swallowing Mercury and Venus. Earth is next in line. The oceans will boil away in hours, and the atmospheric gases will be physically stripped by intense solar winds. The solid mass of our planet will vaporize entirely inside the expanding stellar atmosphere.
This is the baseline standard of cosmic death, a localized, silent erasure of a world. But being consumed by a dying star is a quick, merciful execution compared to the alternatives. Countless other planets suffer a fate far more terrifying than fire. They are the rogue planets. Ejected from their primitive solar systems by violent gravitational instabilities, these worlds are condemned to wander eternally in the interstellar void.
Without a host star, they are plunged into perpetual darkness and a cold so absolute it instantly freezes the very atmosphere into solid snow. An estimated billions of rogue planets drift blindly through our galaxy right now. They are the boogeymen of the cosmos, invisible, impossible to detect, hurtling at millions of miles per hour through the dark. Any life that once existed on these worlds is permanently entombed in ice. But nothing of this compares to what happens to massive stars. While planetary death is a silent tragedy, the death of massive stars is an apocalyptic event. This brings us to the second level of cosmic destruction, the catastrophic core collapse of a supernova. When a star with at least 8 times the mass of our Sun hits iron, the rules of physics shift entirely. Iron is the ultimate cosmic dead end. It consumes energy rather than producing it. In a fraction of a second, the massive core can no longer support its own weight. The core collapses inward at 1/4 of the speed of light. The outer layers crash down into the ultra-dense center and violently rebound outward. The resulting shockwave annihilates any surrounding planets, sterilizing neighboring star systems with a lethal, invisible flood of gamma radiation. The star's physical body is entirely shredded across light years of space. But the violent blast isn't the true nightmare. What crawls out of the stellar debris is a mangled, undead corpse that simply refuses to die. Depending on the original mass, the core remnant is crushed into a neutron star. It is an object so incredibly dense that a single teaspoon of its matter would weigh billions of tons on Earth. Gravity here is a lethal weapon. Some of these neutron stars become pulsars or magnetars. They spin on their axes hundreds of times every second, generating the most powerful magnetic fields in the universe. If a magnetar approached our solar system, it wouldn't even need to touch us. From thousands of miles away, its extreme magnetic force would literally rip the iron from our blood and dissolve the atomic bonds of our bodies. These violent stellar corpses are incredibly hostile, but they are not immortal. Over billions of years, their rapid spinning eventually slows. Their magnetic fields decay. They become cold, silent lumps of ultra-dense neutrons drifting uselessly through the void. But what happens to the billions of smaller, quieter stars that don't explode? Their death is a masterclass in slow, agonizing torture. The vast majority of the universe is not made of massive, explosive stars. 75% of all stars are red dwarfs. They are small, dim, and burn their hydrogen fuel at an incredibly slow rate. While our sun will die in a few billion years, a red dwarf can survive for trillions of years. They are the ultimate cosmic marathon runners. But their long life is a false promise of sanctuary. Red dwarfs are wildly unstable in their youth. They frequently unleash massive stellar flares
that physically strip the atmospheres off any orbiting planets, sterilizing them completely. Any life hoping to survive the death of the universe around a red dwarf will be burned alive by the very star trying to protect it. When these stars finally exhaust their fuel, they do not explode. They simply collapse into white dwarfs. A white dwarf is a dense, glowing ember, roughly the exact size of Earth, but retaining the crushing mass of a star. It generates absolutely no new energy. It simply sits in the dark, radiating its residual heat into the freezing vacuum of space. Because the universe is only 13.8 billion years old, not a single white dwarf in existence has had enough time to finish cooling. Trillions of years from now, they will transform into black dwarfs. A black dwarf is a crystallized sphere of degenerate carbon and oxygen. It is a cosmic diamond floating in a totally dead universe, emitting no light and no heat. But the universe doesn't just execute single stars. Entire galactic cities are already on cosmic death row. Galaxies do not fade quietly. They aggressively tear each other apart in slow motion. The Milky Way is falling toward Andromeda at an astonishing speed of 110 kilometers per second. When they inevitably collide, extreme gravitational tidal forces will warp their structures entirely. The immense interstellar gas clouds will violently smash together, triggering a massive, blinding wave of star formation. This final, beautiful burst of light is actually a death rattle, exhausting the galaxy's remaining gas reserves forever. The supermassive black holes at the center of each galaxy will aggressively spiral toward each other, sending massive ripples of gravitational waves tearing across space-time. The combined galaxy will settle into a featureless swarm of aging red stars. With the structural gas depleted, no new stars will form. As time marches forward into the trillions of years, the entire universe will officially enter the degenerate era. The only objects left standing will be the cold remnants: brown dwarfs, white dwarfs, neutron stars, and black holes. But even in this deeply frozen, dead universe, physics has one last terrifying surprise waiting in the dark. According to theoretical astrophysicist Matt Kaplan, black dwarfs are not the peaceful graves they appear to be. Inside these frozen spheres of degenerate matter, quantum tunneling allows atoms to fuse at an incredibly slow, microscopic rate. It is a time bomb with a fuse measuring in the undecillions of years. Over an incomprehensible timescale, this slow fusion will produce iron in the core of the black dwarf. Once enough iron accumulates, the dead star will collapse and detonate in a black dwarf supernova. It will be the last burst of light in a universe that has been dead for trillions of years. And here's where the final chapter of cosmic evolution begins. After these final phantom explosions fade, only the true apex predators will remain. When the galaxies finish rotting, only black holes survive. In this decaying universe, even these inescapable monsters will be bled to death. You perceive them as eternal, indestructible prisons of gravity where not even light escapes. But quantum mechanics dictates that they bleed. Quantum fluctuations occurring precisely at the event horizon cause black holes to emit subatomic particles. This physical process, known strictly as Hawking radiation, causes the black hole to slowly, irreversibly lose mass. The timeline for this evaporation is genuinely incomprehensible. A supermassive black hole will take a Google years to evaporate entirely. That is a number 1, followed by 100 zeros, an amount of time so vast that the previous history of the universe is less than a blink. During this unfathomable stretch of time, the black hole shrinks, particle by particle. As it loses mass, its internal temperature rises, and the rate of evaporation accelerates exponentially. In its final microscopic moments, the black hole violently, catastrophically explodes. The last gasp releases a final blinding flash of high-energy gamma rays, equivalent to millions of nuclear arsenals detonating simultaneously. But what happens when the cosmos finally runs out of monsters to kill? The final explosion of the last black hole might be the final event to ever occur. But physics suggests a deeper, more profound horror.
The universe might not just die of old age. The fundamental building blocks of reality themselves might dissolve. This is the theory of proton decay. At a timescale far beyond human comprehension, protons, the stable particles that make up all physical matter, might naturally decay.
If proton decay is real, then nothing is immortal. The crystallized black dwarfs, the frozen rogue planets, and the stray cosmic dust will simply dissolve into a mist of subatomic particles. The universe will lose its physical capacity to exist. Or perhaps the end will come through the Big Rip. Dark energy, which drives the expansion of the universe, might accelerate indefinitely. If it becomes too powerful, it will overwhelm gravity. It will tear apart the remaining galaxies, then the solar systems, then planets.
Finally, the expansion of space will become so aggressive it physically rips apart the atoms themselves. Regardless of the mechanism, the endpoint is identical. After the last flash fades, the universe will reach the heat death. Perfect thermodynamic equilibrium will be achieved. All existing energy will be uniformly distributed across infinite space. No light can shine, and no physical life can ever exist again. The beautiful night sky you admire is a temporary display. Nothing survives.